Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Alrighty, so first of all, I'm going to answer questions from 10.1 over the weekend if you have any questions. Then we'll get started on 10.2. But I do have an announcement. I just want to remind you, if you didn't know, Wednesday is Veterans Day. There will be no classes, no Zoom meetings, no office hour. I'm pretty sure the math lab will not be available. I think the college is closed. So celebrate what veterans have done for you on Wednesday, but no classes. All right. Anyway, so having said all of that, are there any questions from section 10.1? 10.1. Any questions from over the weekend?
I didn't have any, thank you.
Okay.
Neither did I.
Okay.
Neither did I.
Okay.
No, I didn't have any questions.
All right. We're 0 for 4. Well, then we'll go ahead and get started on section 10.2. Now, for the sake of time, I am going to skip the explanation of where this formula came from, but I am going to say this about it. If we take ax squared plus bx plus c equals 0, so sort of the general formula for a quadratic or second degree equation where a, b, and c are the coefficients of those three terms. And we go through the process of completing the square. So like we would divide everybody by a so that it starts with x squared. We'd subtract c from both sides. We take b and divide it by 2 and square it and add it to both sides and go through all those steps. We end up getting this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that thing is called the quadratic formula. Okay, quadratic because of it being dealing with second degree or quadratic equations. Okay. Hey Matt, sorry I'm in a Zoom meeting. I will talk to you later. Okay.
Oh, no worries.
All right.
Okay, bye.
Bye. One of my colleagues is trying to figure out winter quarter schedule. Okay, sorry about that. So this formula right here is something we're going to be using today as well as tomorrow. It's a way of solving second degree equations, not using factoring. So some of you will be happy about that. But you're going to want to memorize that formula. You're going to want to know that because you're going to be using it going on up the math ladder. All right. So let's jump right into how this works. Let's say we've got the following equation: x squared plus 3x plus 2 equals 0. Now, this problem is quite easily factorable. So it seems kind of silly to use the quadratic formula on this, but I wanted to start with an easier one that would factor easily just to verify the solutions. For instance, if we were to factor this thing, we'd get x is negative 2 and x is negative 1. Okay? Now, we're going to come back to that in a minute. Now we're going to go on and we're going to use the quadratic formula. X squared plus 3x plus 2 equals 0. To use the quadratic formula, things need to be in standard form, which they are. I've got everything descending powers equal to 0. So what are my coefficients? Well, a is the implied 1, b is 3, and c is 2. Okay, so now x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Everybody following where I'm getting these numbers? Okay. x equals -3 plus or minus the square root of 9 minus 8, because minus 4 times 1 times 2 would be -8, all over 2. Continuing to simplify, x equals -3 plus or minus the square root of 9 minus 8 is 1, all over 2. Continuing to simplify, x equals -3 plus or minus, well, the square root of 1 is 1, all over 2. So now we've got x is -3 plus 1 over 2, which is -2 over 2, which is -1. And x equals -3 minus 1 over 2, which is -4 over 2, which is -2. So x equals -1 and x equals -2. What do you know? Same solutions. Now, obviously, for this problem, this is like way longer than factoring. But there are problems that don't factor that we can use the quadratic formula on. And then there are problems that we really don't want to factor, even though they do, because maybe the numbers are large or complicated or anything. But this is an alternative way of solving second-degree equations. Any questions before we proceed to another example? All right, then we'll continue on. 6x squared minus x minus 1 equals 0. So we have a second-degree equation in standard form. A is 6, B is -1, and C is also -1. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals, well, let's see here, negative times negative, that's going to be a +1, plus or minus. I also want to point out that notice the -1, the whole thing is grouped. So -1, the quantity squared, is going to be a +1. And then also we've got -4 times +6 times -1, which is going to be a +24 all over 12. I really want to emphasize the signs because that tends to be where people mess up in this process. They get the general idea, but the little teeny details like the signs are where mistakes tend to happen. Okay. X equals 1 plus or minus the square root of 25 all over 12. That is 1 plus 24. So then we get x equals 1 plus or minus, well, the square root of 25 is 5 all over 12. So now that I've gotten it simplified as much as I can, I'm going to take it and write it as two separate answers, the plus and the minus. So this is 6/12 or 1/2. This is -4/12 or -1/3. So x equals 1/2 and x equals -1/3 would be the two solutions. Any questions about that? Okay, let's take a look at another example. X squared minus 18x plus 81 equals 0. I want to go back for just a moment to factoring again. Do you see that this is a perfect square trinomial? Okay, where you're going to get two identical solutions. I want to point that out because I want to show you now what that looks like using the quadratic formula. Okay, so A is 1, B is -18, and C is 81. So we get x equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals +18 plus or minus the square root of, let's see here, negative 18 times negative 18 is going to be a positive 324, minus 4 times 1 is 4 times 81 is minus 324 all over 2. So x equals 18 plus or minus the square root of 0 all over 2. X equals 18 plus or minus, what is the square root of 0? It's 0 all over 2. So basically we get x equals 18 over 2, or x equals 9. And that is a repeated solution. So notice this quantity inside of the radical. In other words, the radicand, the b squared minus 4ac turned into 0, which gave us just one solution. Or we say two solutions, one of them that's repeated. Okay? All right, let's take a look at this one. T squared equals t plus 4. This is no longer in standard form. So we're going to subtract, oops, not 4. Well, we are going to subtract 4, but I was going to do that later. Here we go. Okay, we're going to subtract t from both sides, and we're going to subtract 4. So we get t squared minus t minus 4 equals 0. So now our quadratic or second degree equation is in standard form. A is 1, B is -1, C is -4. Now, when I first introduced the quadratic formula, I said x equals -b plus or minus yada, yada, yada. But now actually we're solving for t. So t would be -b plus or minus the square root of b squared minus 4ac all over 2a. In fact, I have a lovely little song for you in terms of memorizing this. Okay, let's see if I can go back to where it first showed up. Here we go. So it goes like this. -b plus or minus the square root of b squared minus 4ac, b squared minus 4ac all over 2a, all over 2a. There you go. My lovely singing. I know what you're thinking. You're thinking, Mr. Mayo, keep your day job. All right, going on. But you never know. It might help you to memorize it. T equals 1 plus or minus the square root of 1 plus 16 over 2, because we have -1, the quantity squared, so -1 times -1, and then -4 times a +1 times a minus gives us a plus 16. So then we've got t equals 1 plus or minus the square root of 17 all over 2. Okay, now the directions for this particular problem say this. It says solve each equation, approximate the solutions to the nearest hundredth. Now, as I mentioned back in section 10.1, WebAssign doesn't want you to write the plus or minus. So if you were putting these answers into WebAssign, it would probably say something like t equals, and then you'd write 1 plus the square root of 17 over 2, comma, 1 minus the square root of 17 over 2. Okay, so you have separate solutions. Now, I want to go further with this. I want to talk about how you would put these into the calculator. And I think I dealt with this back in 10.1 a little bit, but let's kind of revisit that. So let's take, let's see, this and this. Okay, so this top one, you're going to put parentheses 1 plus the square root. And now if your calculator gives you a parentheses after the square root, you're going to close that up, but then you're also going to close up the entire numerator. Okay, so the red parentheses, if your calculator gives you the square, if you push the square root button and it gives you this, then you're going to want to close it up and then close up the entire numerator. If it doesn't, if it just does that, then you're only going to have that one set around the whole thing. Okay. All right. So now to the calculator, parentheses 1 plus the square root of 17. Mine gives the extra parentheses, so I'm going to close that up, close it up again, and then divide by 2. And I get 2.5615, etc., rounding to the nearest hundredth. The 6, I'd go one place to the right, the 1 would round down, so I'm going to get 2.56. Okay, now let's do the second one. Parentheses 1 minus the square root of 17. Parentheses divide by 2. And let's see what I get for that. I get negative 1.56155, etc. So again, the 1 would round down, so I'd end up with negative 1.56. So my two approximate solutions would be that. So these are the exact solutions. These are the decimal approximations. Any questions on that? Okay.
No.
Yes? Oh. you're
I
good.
said no.
All righty, great. Oh, let's see here. Let's do this one. 3y squared equals 12y minus 4. So to put this in standard form, I will subtract 12y from both sides and add 4 to both sides. So I get 3y squared minus 12y plus 4 equals 0. So now it's in standard form. Identifying my coefficients, a is 3, b is negative 12, and c is 4. So y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Continuing to simplify, y equals 12 plus or minus the square root of 144. Let's see, we've got minus 4 times 3 is minus 12 times 4 is minus 48 all over 6. So y equals 12 plus or minus the square root of 40. Let's see, 144 minus 48 would be 96 all over 6. Now, it would be great if 96 is a perfect square. I'm pretty sure it isn't. I go to my calculator. No, it isn't. But I can simplify the radical again, like we did back in chapter 9 or in 10.1. The square root of 96 would be the square root of 16 times 6, which would be 4 square roots of 6. So now I'm going to put this in the place of that, and I'm going to get y equals 12 plus or minus 4 square roots of 6 all over 6. Okay, now looking at my answers so far, and I look at all 3 pieces, I can see that all of those have a common factor of a 2. Right? So what I'm going to do is I'm going to factor a 2 out of the numerator, and I'm going to factor a 2 out of the denominator so that I can reduce this whole thing down. Now, up on top, taking out a 2, I'd have 6 plus or minus 2 square roots of 6. And again, where do I get that? There's the 12, and there's the plus or minus 4 square roots of 6 that I started with. So now I can get rid of this, and I have y equals 6 plus or minus 2 square roots of 6 all over 3. Okay. So that would be the way you would answer that. You'd reduce it down. So you wouldn't stop there. Now, again, in WebAssign, you'd write those separately. 6, let's see, what is it? 6 plus 2 square roots of 6 all over 3. And 6 minus 2 square roots of 6 all over 3. And once again, we'll go to the calculator for a decimal approximation, rounding to the nearest hundredth. Parentheses, 6 plus 2 square roots of 6, close that up, close up the whole thing, divided by 3. And I get 3.6329, which is going to round off to 3.63. Okay. And doing the minus, I get 0.36700, etc. So that's going to round off to 0.37. So here's my exact answer, decimal approximation. Exact answer, decimal approximation. Any questions about that problem? Okay. Now we're going to look at some problems. We're not going to actually plug them into the quadratic formula, but we're going to do a step to make the numbers nicer. So first of all, let's say we've got negative 5x squared plus 9x minus 2 equals 0. Well, let's go back to the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Notice that there is an a in the denominator. It tends to be nicer or easier to divide by a positive number rather than a negative number. Also, think back to factoring, how I said that it was better to have your leading coefficient positive. So for a couple of reasons, it would be nice to make that positive. So what we can do with this problem is basically just multiply both sides by -1, which gives us 5x squared minus 9x plus 2 equals 0. Now, from there, a is 5, b is -9, and c is 2. But we're not really interested in finishing it. We just wanted to look at, oh, here is a move we can make to get our numbers nicer. All right, so if your leading coefficient is negative, you could multiply both sides by -1. All right, another example. Let's say we've got 1.6t squared plus 2.4t minus 0.9 equals 0. So now we've got decimals to deal with. Well, let's see. Each one of these has 1 digit to the right of the decimal point. To move everything over 1 digit, we'd multiply by what? 10. Okay. So 10 times 1.6t squared would be 16t squared. 10 times 2.4t would be plus 24t. 10 times minus 0.9 would be minus 9. And 10 times 0 is 0. So here again, we now have nicer numbers, 16, 24, and -9 as our A, B, and C. You could use the decimal numbers and put them into the quadratic formula, but it tends to be easier to calculate them using whole numbers. Anyway. Questions on that?
No.
All right. Next example. Let's say that we have a bunch of fractions to deal with. We could clear the denominators by multiplying both sides of the equation by the LCD, which is 8. So then we'd get 8 times 1/8 x squared plus 8 times 1/2 x minus 8 times 3/4 equals 8 times 0. And notice I put the minus sign in front. I could have written plus 8 times -3/4. Ultimately, I'll end up with the same thing, and that is x squared plus 4x minus 6 equals 0. So now A is 1, B is 4, and C is -6. You really, really, really don't want to use fractions in the quadratic formula if you can help it. It just gets really ugly really fast. So if you've got an equation like this, I would highly recommend you clear the fractions before you plug the numbers into the quadratic formula. Okay. And finally, let's say we've got something like this: 33y squared plus 99y minus 66 equals 0. Well, we don't have any fractions or decimals, but we could still make these numbers nicer. We could make them smaller. We could factor out a 33. And then divide both sides by 33. So basically you'd have that, where a is 1, b is 3, and c is -2. And then you can use those numbers for your a, b, and c. Okay. Let's take a look at some other examples. Let's see here. We've got x squared equals -5/4 x plus 3/2. So the first thing I'm going to do is put this in standard form. I'm going to add 5/4 x to both sides and subtract 3/2 from both sides. So I get x squared plus 5/4 x minus 3/2 equals 0. So now I'm going to multiply both sides of the equation by what? 4. Good. So I'm going to get 4x squared plus 5x minus 6 equals 0. Is everybody okay with how I did the reducing there?
Yes.
Okay.
Yeah.
Good. So a is 4, b is 5, c is -6. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals -5 plus or minus the square root of 25 plus, because -4 times 4 is -16 times -6 would be plus 96 all over 8. X equals -5 plus or minus the square root of, let's see, what is that? 121 all over 8. X equals -5 plus or minus 121 is a perfect square. It's 11 squared. So the square root of 121 is 11 all over 8. Sounds like Thanksgiving. Everybody, all over 8. Sorry. Okay. X is -5 plus 11 over 8, which is 6 over 8, which is 3/4. Or X is -5 minus 11 over 8, which is -16 over 8, which is -2. So X equals -2 and X equals 3/4 would be the two solutions. All right with that?
Yes.
Yes.
Okay, let's take a look at this problem. Let's see. X times the quantity x minus 27 equals 280. So to get this thing in standard form, we're going to distribute the x like that. Then we'll subtract 280 from both sides. Oops, that was supposed to be minus 27x. And then we'll get that. Okay, so a is 1, b is -27, and c is -280. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. See if I can write that a little nicer. Okay. So x equals positive 27 plus or minus, let's see, negative 27 times negative 27 would be positive 729. And then minus 4 times 1 would be negative 4 times negative 280 is going to be plus, let's see, 4 times 1 times 280 is 1120 all over 2. So x equals 27 plus or minus the square root of 1120 plus 729 is 1849. That's not the year I was born. That's the year I graduated from kindergarten. And then we've got x equals 27 plus or minus. Let's see. Hopefully the square root of 1849 is nice. Let's see if it is. 1849. Good. 43. So x equals 27 plus 43 over 2, which is 70 over 2 or 35. X equals 27 minus 43 over 2, which is negative 16 over 2 or negative 8. So x equals 35 and x equals negative 8. Okay with that?
Yes.
All righty.
Yeah.
Let's see. Good. How about this one? 0.6x squared plus 0.03 minus 0.4x equals 0. Well, the first thing I'm going to do is rearrange the terms so that they're in standard form. 0.6x squared minus 0.4x plus 0.03 equals 0. Okay. Let's see. Oh, to get everything decimal free, we'd have to multiply by what?
10. 100?
100. Yeah,
Oh, I didn't see that one.
that's okay. So I'm going to move the decimal point over 2 places. So 100 times 0.6 would be 60 x squared. 100 times 0.4 would be minus 40 x. And 100 times 0.03 would be 3. And then 0 times 100 is 0. Okay. So now A is 60, B is negative 40, and C is 3. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals 40 plus or minus the square root of 1600 minus, let's see here. So 40 times 40 is the 1600. And then you've got minus 4 times 60 times 3 is minus 720 all over 120. Okay, so x equals 40 plus or minus the square root of 1600 minus 720 is 880 all over 120. Well, I don't think so, but let's see if 880 is a nice perfect square. It's not. So now we're going to do some simplification. Well, let's see. 880. If I broke that down, that would be what? 88 times 10, which is 8 times 11 times 2 times 5, which is 2 times 2 times 2 times 11 times 2 times 5. Let's collect all of those 2's. So we'd have 2 to the 4th times 5 times 11. Okay, I'm going to take this and go on to the next screen. x equals 40 plus or minus the square root of 880 all over 120. And then, let's see here. Back here, we've got 880. So 880 is 2 to the 4th times 5 times 11. 2 to the 4th times 5 times 11. So that becomes that, which would be what? 2 squared or 4 square roots of 55. Okay, do you need me to go back to the previous screen at all?
No.
All right, so this is going to go there. Okay. X equals 40 plus or minus 4 square roots of 55 all over 120. So now looking at this and this and this, they all have a factor of 4 that's common. So I'm going to factor a 4 out. Okay, so this would give me 10 plus or minus the square root of 55 over 30. All right with that?
Yes. Yes.
So now I'm going to have x equals 10 plus the square root of 55 over 30. And x equals 10 minus the square root of 55 over 30. So those would be your two exact solutions. Now, decimal approximations to the nearest hundredth. Let's see here, parentheses, 10 plus the square root of 55, close up the square root with a parenthesis, close up the entire numerator, divided by 30, and I get 0.5805, etc. So to the nearest hundredth, that would be 0.58. And the negative 0.08612. So that would be what? 0.09. So there are your exact solutions and your decimal approximations. Okay, so work on memorizing the quadratic formula. Techniques that you can use to simplify numbers before you deal with them. If there's decimals, you can multiply by 10 or 100 or 1,000 to clear them out. If there's fractions, multiply by the LCD to clear them out. If the numbers are large and there's a common factor you can reduce out, do that to make it nicer to deal with the quadratic formula itself. All right, well, that's all I have for you today. Tomorrow we'll come back and we'll finish up this section looking at application problems. So if I don't see you this afternoon, I'll see you tomorrow.
Thank you.
Thank you. Have a great day.
You too.